Welcome. In this video we will be learning about solving applied systems of a linear equation by using Gauss-Jordan elimination. So we want to solve this word problem by using the Gauss-Jordan elimination of two variables. And the reason why I know I have two variables is, first, let's read the problem. It says Turi's t-shirt shack sold 36 shirts in one day. Each short sleeve t-shirt costs $12. Each long sleeve t-shirt costs $18. Total receipts for the day is $522. How many of each kind of shirt were sold? So remember, for any word problem you have, it's nice to know what we're looking for. So I want to let X be the number of short sleeve t-shirts. And I want to let Y be the number of long sleeve. And since we are talking about money, let's use the formula price times quantity is equal to cost. In terms of the short sleeve, the price is $12. I do not know how many of them I want to sell, so I want to let that be X. And the revenue or the cost that I want to generate for that day is going to be 12X. For the long sleeve, the price of it is $18. I do not know the number of long sleeves I'm going to sell, so I'm going to let that be Y. And the revenue I'm going to generate from that is going to be 18Y. I do know that I'm going to sell 36 shirts today. So if I add the number of long with the number of shorts, that's got to be 36. So that's going to be my equation 1. I do know if I take the revenue from the short, add it to the revenue of the long, that's going to give me 522. And that's going to be equation 2. My augmented matrix is going to be 1, 1, 36, 12, 18, and 522. And when I do RREF with matrix A, I will get the answer of 1, 0, 21, 0, 1, 15. That means that X is equal to 21 and Y is equal to 15. So there's 21 short sleeves and there's 15 long sleeve t-shirts. The hardest problem about word problem is the setup. And then once we have the setup, if we're using the graphing calculator, then the RREF button is what we would want to use. Take a look at this coffee mixture. It says the owner of the Daily Grind coffee shop mixes French roasted coffee worth $9 per pound with Kenyan coffee, which is worth $7.50 pounds, in order to get 10 pounds of mixture worth $8.40 per pound. How much with each type of coffee was used? So what we have here is we're wanting to find out how much are we going to use of the $9 one with the Kenyan coffee, which is $7.50, in order to produce an $8.40 coffee. So the two things I'm looking for is I'm looking for the number of pounds of the French roast and the Y is going to be the number of pounds of the Kenyan coffee. Because we're talking about money, we got to remember the equation price times quantity is equal to cost. And we have the two different prices. We have the French roast, which is worth $9. We're adding that to the Kenyan. That's worth $7.50. In order to produce a combo of $8.40. So we're adding the French with Kenyan in order to do a combination. But the question is how much of the French do we actually have? Do we know? No, let that be X. Do we know how much of the Kenyan we're going to use? No, let that be Y. But do we know how much of the combination we're going to have? It says that we need 10 pounds of it. So that means that the X plus Y has to be equal to 10. That is equation 1. What about the cost? The cost for the French roast is going to be 9X. The cost for the Kenyan is going to be 750Y. And the cost of the combined is going to be 840 times 10. The sum of the French roast and the Kenyan has got to be equal to the combined. So your second equation is going to be 9X plus 750Y is equal to 84. Because that's what 840 times 10 is. Augmented matrix. And your answer. I get X is equal to 6, and that is 6 pounds of the French roast. And I get Y is equal to 4 pounds of the Kenyan coffee. Now let's take a look at a 3-variable problem in terms of interest. So it says borrowing. The manufacturer borrowed $30,000 to buy a new piece of equipment. Part of the money was borrowed at 8, 10, and 12. An annual interest of $3,040. And the total amount borrowed from the 8% and the 10% was twice the amount borrowed at 12%. How much was borrowed at each rate? So again, we don't know how much we borrowed at each, so we're going to say let X be the amount of money borrowed at 8%. Let Y be the amount of money borrowed at 10%. And we're going to let Z be the amount of money borrowed at 12%. We are talking about interest, so we got to know that rate times principal is equal to interest. We have to make sure the rates are written as a decimal, so that gives me a 0.08, a 0.10, and a 0.12. The principal borrowed at 8% is unknown, so we call that X. The principal borrowed at 10% is Y. The principal borrowed at 12% we labeled Z, but we do know that the total amount borrowed was $30,000. So that's going to be equation 1. X plus Y plus Z is equal to 30,000. The interest that is borrowed off of each is earned every year. And the interest is going to be the product of the 0.08 times X, the 0.10 times Y, the 0.12 times Z. All of that added together will accrue the annual interest of $3,040. And that is equation 2. 0.08X plus 0.10Y plus 0.12Z is equal to the interest of $3,040. Normally, if we have 3 variables, we need 3 equations. The last equation that we're going to have starts off on the 3rd line from the bottom. It says the amount borrowed from the 8 and the 10. Okay, so the amount borrowed at 8 was X. The amount borrowed at 10 was Y. Together, that equals to twice the amount of money invested at 12, which is twice as much invested at Z. So since we're talking about money, we're looking for the variable and not the percentage. But for equation 3, it's got to be in proper format. Let's subtract the 2Z from both sides. And that means that my augmented matrix is going to be 1, 1, 1, and 30,000. 0.08, 0.10, 0.12, 30, 40, 1, 1, negative 2, and 0 for the row 3. And my answer is 1,008,000, 0,10,12,000, and 0,01,10,000. So that's a translation of X is equal to $8,000 borrowed at 8%. Y is equal to $12,000 borrowed at 10%. And Z is equal to $10,000 borrowed at 12%.